Hi. We're going to start our first lesson of this year. Something that maybe you'll remember from Algebra 1, but it's really important. Looking at key features of a function. Specifically today, we're going to talk about x and y intercepts, how to find them both from a graph, or if you're just given an equation. And we'll talk a little bit about why it's so important to find these and how when you talk about real world problems, what they could represent in the context of the situation. So looking at this graph, there's several things. I'll give you a list here of how if you were going to try to describe to someone what you were seeing, different pieces that you could talk about that would allow them to actually draw the specific graph that you're referencing. All of these are things we'll be talking about in this first unit of our course material. And specifically today, we're going to talk about x and y intercepts. All right, so maybe you remember the term here, but it's really easy to mix them up just because their names are so similar. So the word intercept, let that remind you of something crossing. If you intercept the ball, you're at where the other player is and you're taking it from them, so it's somewhere where you're meeting. X-intercept, remember we have our horizontal line we refer to as the x-axis, and the x-intercept is where our graph crosses the x-axis. And likewise, our y-intercept, remember our vertical line is the y-axis. So the y-intercept is where our graph crosses the y-axis. So here is a graph of a line. And just another example, you could have something that's not a line. It's also going to have these x and y intercepts, possibly. And notice right here at this graph, we actually have two x-intercepts. And it's possible to have even more than two, depending on the type of graph you're talking about. With a y-intercept, we'll get more into this year, but if we're talking about a function, you could only have one y-intercept. But if we're talking about something that's not a function, then it is possible to have more than one y-intercept on a graph. It's also possible to have 0 y-intercepts and 0 x-intercepts on a graph, just to keep that in mind. So if we're looking here, if we're given the graph and we're asked to find the x and y intercepts, we're just going to zero in to our x-axis. So notice we have two x-intercepts, and the y-intercept for this quadratic here, we have one y-intercept. And likewise over here, x-intercept, x-intercept. I could label those coordinates. This is happening at 1, 2 to the right. And notice a height of 0. Likewise, the other x-intercept is at 4, 0. Okay, I'll label that. And our y-intercept, that arrow tells us that graph is going to keep going. So our graph will cross the y-axis at 0, 4. All right, and now we're given the equation there. So if you are not given the graph, like the example right here, and you're asked to find the x and y intercepts, you don't necessarily have to draw the graph to then get the answer. It would be quicker just to go straight to it algebraically. And we can do that if you think about what you're seeing right here. If you are an x-intercept, you have to be on the line, the x-axis. Any point on this line has a height of 0, which is the y value. So your y value will always equal 0. So if you are trying to find the x-intercept, all right, that is where y equals 0. So we can take that and use that, plug 0 in for y. So if 0 equals y, we can solve for where that's true, the x values, in this manner. And now we just want to solve an equation like you did in Algebra 1. So to do this, we'd want to get the x value by itself. We can do that by adding 3 to both sides. And remember, these straight up and down bars, they're absolute value bars. Whatever you put inside the absolute value bar has to come out positive. It really represents the distance from 0. So if you're going to have a distance of 3, that's true if you're the value 3. So if x equaled positive 3. That's also true if x equals -3. because the distance of -3, picture a number line, from 0 is still just 3 units. So we really have 2 x-intercepts, and I can write those coordinates with an x value of 3, a y value of 0, and an x value of -3 and a y value of 0. All right, the reverse is true. If you're going to find a y-intercept, you're on this vertical line here. All right, that means you haven't moved at all to the left or to the right. So your x value equals 0, and notice that's true in this coordinate here. So if we go and find the y-intercept, we're going to plug in 0 for x. So we'd say, okay, the y value equals the absolute value of 0 minus 3. All right, the absolute value of 0, what's the distance 0 is from 0? Well, there's no distance, and nothing in number sense is still just 0. So y equals 0 minus 3, and 0 minus 3, that's just -3. So our y-intercept is at 0, -3. All right, and we can start to sketch our graph, and we get a pretty good sense just from these 2 key characteristics of what this graph actually looks like. All right, another example. I won't talk through all of the steps here, but I'll just go ahead, same thing, to find the x-intercept. Y equals 0. Y-intercept, maybe you work it and pause the video and then check out the answer. So y equals 0. All right, this is a little tricky here. You gotta remember when you take the square root of a value, if you square a number, you square a positive number, it stays positive. But also if you square a negative number, the result is positive. So the square root of 4, we've got to consider both the positive and -2, because -2 squared, -2 times -2 is also 4, and 2 times 2 is 4. So our answer is -2, 0, and 2, 0 for our 2 intercepts. And when we get to solving for the y-intercept and we say 4 minus 0 squared, 0 squared, 0 times 0, that's just 0. So y equals 4 minus 0, or y equals 4. So our y-intercept will be 0, 4. Okay? You're going to notice this year, and then next year in pre-calculus, and then take calculus, your answers are going to get uglier and uglier. Think about the real world. All right, we don't get to pick what the answer is, we're finding the answer. So a lot of times we have messy numbers. So do not be surprised if you start to get weird fractions or decimals as your answers. You're not necessarily wrong. That's going to happen more and more. So there are fractions and decimals everywhere. Makes it more fun. Okay, just a little summary right here for you. X-intercepts, all right, they're going to be important. You'll see that when we talk about all the real world situations. So they have nicknames. It's going to pop up a lot in math. One very common name for this, the zeros of a function. And think about why that's true. Could kind of make this argument for both x and y intercepts, but when you are on the x-axis, your y value is 0. So we call these x-intercepts zeros. Another term, roots. Okay, we'll use all 3 of these terms this year. And when we are finding those algebraically, we let y equal 0, and then we solve for x. And then likewise, y-intercepts, they are found by letting x equal 0, and then solving for y. Okay, I'll stop this video here, and then I'll do another one talking about the word problems.